Good morning. My name is Mbaye Mbeguere. I am from the Senegal National Sanitation Utility, a Senegalese government utility dealing with sanitation on urban areas. And I was for 5 years appointed as a project manager at the Swiss Federal Institute of Aquatic Science and Technology, dealing with sanitation in developing countries. And I was lecturing for 10 years at Dakar University on sanitation issues. And right now I'm coordinating at ONAS a gate-funded project on the structuration of fecal-sludge market. If you want to learn a little bit more about our background, about what ONAS is dealing with, you can visit our website, onasbv.sn. We are together this morning, and we want to talk about treatment technologies, principles and mechanisms of settling tank, drying bed. And when we talk about drying bed, we want to talk about unplanted drying bed and planted drying bed. But before we go further in this perspective, I just want to explain that fecal-sludge management is a whole value chain that must be managed globally, from collection to transport to treatment and reuse. The goal is to make sanitation services safe and sustainable by addressing the failure to effective collection and transport, treat and reuse waste captured on on-site sanitation facilities. Right now, the technological issue is something very important in fecal-sludge management, but must accompany a process of organization of the whole segment of the chain so that collection and transportation was done properly and was affordable for beneficiaries on site sanitation. In most of the cases, when people talk about technology, about fecal-sludge management, people think about technology without thinking about all that need to be around. And this is why many fecal-sludge management built in Africa was not working, or was always waiting right now for fecal-sludge. These pictures show some fecal treatment plant implemented in Lomé, in Bamako, in Ouagadougou, in Accra, and all these fecal treatment plants are not working or are waiting for fecal-sludge. And for this lecture, we will talk about fecal-sludge treatment technologies. I would even say about fecal-sludge pre-treatment technologies. Why fecal-sludge pre-treatment technologies? Because we realized that after the treatment, the processing by drying bed, by settling tank, by implanted drying bed, we realized we need a post-treatment. We need a post-treatment. It is why I prefer talking about fecal-sludge pre-treatment technologies. And for 1 hour and more, we'll talk about drying bed, about unplanted drying bed, and about settling thickening tank. What are the main mechanisms we have in these technologies? In settling tank, in drying bed, and in unplanted drying bed. We realize that many treatment systems for fecal-sludge are based on system for wastewater treatment and treatment of wastewater sludge. This is a big mistake because we realize that fecal-sludge and wastewater are not the same. I will talk a little bit more about that in my next slide. And because we can find major differences between these two kinds of waste due to the high variability in concentration of all constituents. We can say that fecal-sludge management, fecal-sludge is very different from wastewater in terms of volume, in terms of concentration, and therefore in terms of charge. Several analyses and several measurements we made in several countries allow us to understand that 1 liter of fecal-sludge equals 100 liters of wastewater. It means you cannot use the same system to treat fecal-sludge and wastewater. The design of a fecal-sludge treatment plant need to conduct a lot of analysis due to the high variability that characterize fecal-sludge. Both within a country and between two countries, you realize that sludge varies widely. And you cannot use, for instance, data from Ghana to design a fecal sludge treatment plant in Dakar. This is a mistake. And for instance, if in Ghana, where you have some public toilets, you realize after measurement that fecal sludge is very different in country like Senegal, where facilities are residential and consisting of septic tank. And fecal sludge management characteristics depend on several parameters. And depending on the technologies used on collection and on transportation, sludge can vary widely. If you want to implement or to design a good fecal treatment technology, you have to keep on mind several parameters. I talk about the degree of stabilization. You have to link this to the kind of facilities you have at the household level, because according to the fact you have a latrine or a septic tank, you will realize that the degree of stabilization will be very different. The organic load is something also very, very important, because it can inform about the kind of post-treatment we have to implement later on after the settling tank, after the drying bed. Also the water content is very important, because it can inform about the solid liquid separation treatment we have to implement in order to improve the quality of this water. And fecal treatment mechanism are of three types. You can have a physical mechanism, you can have a chemical mechanism, you can have also a biological mechanism. And we must know that fecal treatment technologies are not as well understood as those of wastewater. The understanding is very limited, and we realize that the design of this technology is based mostly on empirical data. This is why we need to gather more evidence for the fecal treatment plant, for the design of treatment technology. This is why, fortunately, several international institutes like IAVAX, the Swiss Federal Institute of Technology, like IHE, like AIT in Thailand, and some utilities like ONAS work on this perspective in order to get more evidence for the design of fecal sludge treatment technologies. About the physical treatment, what is the objective? The objective of this physical treatment is just to allow a solid liquid separation in order to reduce the volume of water. You realize that all this will lead to a dewatering process, because dewatering is something very important in fecal sludge, because we realize that in fecal sludge you have more than 95% of water content, and in this condition you realize you cannot dump this waste with this water. This is why the first thing to do is to dewater, and this dewatering can allow to reduce the transportation cost of this waste. And when you dewater also, you realize that you disinfect. You can reduce the quantity of pathogen you can have inside this water. And it is also essential for resource recovery, because you can get, after dewatering, a solid fraction and a liquid fraction. And the solid fraction, when treated correctly, can be used as compost for fertilizers, and you can use also the liquid in agriculture or in market gardening, for instance, which is very important in developing countries. What processes are inside these physical treatment? You can use several kind of processes: evaporation, evapotranspiration, filtration, and infiltration. And you can realize that all this will allow to reduce the volume of liquid to dewater, and all these processes play a key role in this dewatering process. About the chemical treatment? We know that coagulation and flocculation are important processes in water treatment. With coagulation, to destabilize particles through chemical reaction between coagulant and colloids. Colloids are particles inside in fecal sludge with very, very, very small density, and with flocculation, which transport these destabilized particles and make them settle. And the objective of this chemical treatment is to improve performance of physical treatment to inactivate pathogen. However, we have to keep in mind that it can be very expensive, because you have to use some chemical like alkaline, like ammonia, and this costs a little bit and make the treatment more expensive. The biological treatment is also another process involved in treatment technologies, and this biological process can be an aerobic treatment, can be a non-aerobic treatment, and the main objective is to stabilize. But we realize after the physical and the chemical treatment, when we put in place these kind of treatment, we realize that the quality of water treated is also very low. You have so much nitrogen, you have so much phosphorus, you have so much I can say pollution inside, and you have also so much pathogen. It is why it is obvious to develop a further treatment in order to reduce the organic content and in order to eliminate pathogen. This is why the stabilization is something very important. And stabilization involves the degradation of petrifiable, readily degradable material, leaving behind more stable, less degradable organics. Stabilized organic matter does not have an exact agreed upon scientific definition, but in general refer to resistance to further biodegradation. To summarize all this, we can say that treatment, several mechanisms are involved with fecal sludge treatment. We can have a physical one with settling, thickening, evaporation, evapotranspiration, infiltration. And all these mechanisms led to a dewatering, led to a reduction of the water content of fecal sludge. After that, we can have a chemical treatment with coagulation, flocculation, and the objective is just to improve the dewatering or the solid liquid separation process already involved or already in place at the physical treatment site. But don't forget that the chemical products can enhance the cost of the treatment and can make it more expensive by using some chemical product. After that, you need to improve the quality both of the liquid fraction and the solid fraction, because you have so organic and so pathogen inside, by conducting a biological treatment. And this biological treatment can be done by plant uptake in unplanted drying bed, by aerobic degradation, by anaerobic degradation, and also by aeration, thanks to the plant you have to implement in unplanted drying bed. What are the main factors influencing the quality of fecal sludge? Why fecal sludge is very different from Dakar to Ghana, from Ghana from Dakar to Accra, from Accra to Bamako, and from Bamako to Thailand, for instance. It is very different because the technology and the emptying mode are very different. If, for instance, in the country you deal with manual emptying or with mechanical emptying, you realize that the quantity of solid inside the fecal sludge will be very different. Because in a manual emptying, you realize that emptiers can mobilize all the fecal sludge, or in mechanical emptying, you realize that sometimes only the liquid part is pumped. In Dakar, for instance, we have 150 trucks working every day to empty the fecal sludge content of the pit, but we realize that 60% of these trucks are pumping truck. And when you have a pumping truck, we realize that this truck can pump only the liquid, because the pump is not enough strong in order to mobilize the fecal sludge. It means at the fecal sludge treatment plant you have a very liquid fecal sludge, because all the solid content remain inside the pit. It is why, according to the kind of technology you have in your country, it can impact on the quality of fecal sludge you have. The storage duration is also something very important, because according in a city like Ouagadougou, for instance, you have more latrines than septic tank.
and you have to empty this latrine so often, and in this condition you realize that the concentration of the level of stabilization will be very different than in Dakar, where with septic tank you can store the sludge for 2 to 4 years, and in this condition you can have a very stabilized fecal sludge. The quality will be different. For instance, I just give an example. In Dakar, we planned it with the Gay Foundation to implement a biogas treatment system, and we realized, thanks to the quantity of organic matter we have in the sludge, that a biogas system will want to be profitable in Dakar. And in Ouagadougou, because they are latrines, we have so much organic content ready to be stabilized, ready to be to go to a further degradation in order to get more methane, for instance. This is why the storage and the kind of facility will be very, very important. The composition of fecal sludge is also very, very determinant. For instance, if you have breeze, waste content, all this will make fecal sludge different from a country to another one. The groundwater is also very important. In Dakar, in some part where the water table is very high, we realize we have every day infiltration of groundwater into the pit. And what is the consequences is we realize that this sludge is very diluted, and when you make analysis you have something like a wastewater. This is why you can have several situations with several different kind of fecal sludge. Fecal sludge may also contain several things like sand. You can have also solid waste like clothes, broken bottles, batteries, bags, plastic bottles, metal syringes. You can have also pharmaceuticals, chemical pollutants from craft industry, oil, dyeing effluent, and so on and so forth. This waste looks like garbage. It is why you need, if you want a good fecal sludge treatment system, to make a good screening before the treatment. A screening is very important, and you have also to put in place a good organization to transport this solid waste to a landfill. It is something important. If you say, my concern is just to treat fecal sludge, you realize you have some garbage beside, and you need to take it over. Dakar experience show that a succession of 2 grids before the settling tank or before the drying bed is something very important. If you put 2 grids with a respective bar distance of 20 millimeter and 25 millimeter, you can eliminate a big part of solid waste. But you need to clean every couple of hours this grid in order to remove all the solid content we arrive to eliminate with such a grid, and to put this waste to a landfill. This is why the success of a good fecal treatment plant can only be achieved through a good system of screening. It is something very important. Now, what kind of treatment technologies after the screening process we have to implement in order to improve the quality of fecal sludge? Several treatment systems are used in fecal sludge management, and this system can be co-composting with organic solid waste. We can have some planted drying bed. We'll talk a little bit more about that. We can also implement an unplanted drying bed. A settling tank is also a used technology we use all over the world. A settling pond, an aerobic digestion, a core treatment of fecal sludge with sewage sludge, a core treatment with wastewater. But we have to keep in mind that all these systems generate both a solid fraction and a liquid fraction. And this solid and liquid fraction need to be further treated in order to improve their quality. It is something important. It is why in the beginning I don't talk about fecal sludge treatment technologies, but I talk about fecal sludge pre-treatment technologies.
because after that, after the drying bed, after the planted drying bed, after the unplanted drying bed, after the settling sinking tank, you need always to implement a post-treatment. And when these solid fraction and liquid fraction are treated correctly, are post-treated correctly, you realize you can use the solid fraction in agriculture. You also use the water for irrigation, for instance. Or the solid fraction can be also used as fuel, as we plan to do with the omniprocessor in Dakar, as we, Yaba Sandek, work with the Senegal National Sanitation Utility in order to use this fraction as fuel for cement factory. This is why this post-treatment is very important, because it allows to create some added value from the fecal/treatment technology. Now we talk a little bit about settling sinking tank, the first technology we have to deal with in this course. And this picture is an illustration of fecal treatment plant in Rufisque, near Dakar, the capital city of Senegal, and in Ghana, in Accra, in Ghana. And all these systems are working right now properly. What about the settling sinking tank? We realize that this fecal settling sinking tank works like a big open septic tank. If you know a septic tank, it works like a big open septic tank with a short residence time and with a solid liquid separation, which allow the formation of several layers. We have in the bottom a solid layer, you have also a water layer, and you have a third layer with grease, so call it scum. And the settling process that began immediately after the feeding of this bed is followed by a longer thickening process, resulting to a more compact fecal sludge. But we need to be attention, because a long thickening time undermine an effective pumping of thickening sludge to the other bed, to the drying bed, for instance. It is why you need to be very quiet about this aspect. In Dakar, for instance, we realized that after 1 week feeding of this bed, we can have 1-2 week thickening in order to get a more compact fecal sludge. We have to try further in drying bed. We conduct several sedimentation tests in Dakar and in Accra, and we realize that the volume of settled sludge can be roughly around 30-35 of the initial volume. But we realize also, thanks to this test, that the public toilet sludge does not settle easily because we have too much bound water. To have a good settling thickening tank working properly, you have to avoid the maximum possible the turbulent, no turbulent flow. It is why we implement some baffles in the entry of the settling thickening tank. The ratio between width and the length can be 1:5:10. And as I explained earlier, not fresh sludge alone. You need to mix this fresh sludge to a more stabilized sludge in order to make it settle easily. Normally, we have two settling thickening tank units alternately operated. The performance of the settling tank depends on the operation mode. As I explained in the last slide, 1 week of loading is sufficient, and after that, you can have 2 weeks of thickening in the settling thickening tank in order to make more compact the sludge. And you have some issues when processing fresh sludge because of the poor sedimentation. And we realize that in several African cities, you have so many public toilet, and in these public toilets you can get some fresh sludge. It is why we have to think a little bit more about the treatment of this sludge. Here you have a dislodging of fecal sludge in Accra, in Ghana, and as I explained also, we have to know that always we need after treatment, because liquid and solid are still high in pathogen, sludge not yet stabilized or fully dewattered. But we can also say that fecal septic tank is especially beneficial when treating fecal sludge with low solid in temperate or rainy climate. And when you use a settling tank, you can reduce the area of following treatment steps. You can reduce the footprint of your fecal sludge treatment with such a technology. In the post-treatment aspect, we can use a stabilization pond, and the stabilization pond is something very important because it allows very low maintenance, because we have some cones with this technology, because we need so much area for the implementation of this technology. The footprint is so high with the stabilization pond, and this space is a big issue in cities, in developing countries. And also a major problem is it is difficult to treat fresh sludge with stabilization pond due to the high concentration of ammonia we have inside. We need to operate a good settling thickening tank. We need sufficient volume for sludge accumulation. We need also a sufficient depth, more than 1.5 meter. A loading resting cycle much shorter than in sedimentation pond, where we have several months for this resting cycle. We need buffer in order to make the basin more turbulent and to allow a good settling and a good thickening of the sludge, and to allow also a good retention of floating scum. And we need for the design to plan an accumulating sludge of 5 to 9 liters per kilo of total solid, and we need also to take care about the scum, because this basin is from Canberra and fecal treatment plant in Dakar, and you realize that if you don't take care correctly with this scum, you can have some plant growing on it, and it doesn't work properly in this condition. The sludge volume index is a very important parameter. It is an empirical method to determine settleability of sludge, and for this you use some Imhoff cone like what we have in this photo, and you have to just calculate the volume of fecal sludge settled in this cone during 1 hour. And with this sludge volume index, you can calculate the quantity of total solid you can have in your basin, and it can help you to design correctly this technology. What about the removal rate? We try in this slide to compare what happened in a sedimentation pond and in a settling tank, and we realize that according the physical pollution and according the organic matter, you realize that the settling tank is working correctly. We can have more than 90% of retention of the suspended solid, and you realize that the organic matter is also correctly retained due to the fact that this organic matter is mainly solids, and in this condition you can eliminate between 70 to 95% of this organic matter. And we compare also several treatment technologies from Dakar to Accra, and we realize that this technology is very efficient. When you have a long thickening time, you can improve the quality of this water, but you realize that you will face several difficulties to remove this sludge from the tank. You have to balance between this thickening time and our objective to pump this sludge into the drying bed. With this formula, it is important with this formula you can calculate the quantity, the concentration of total solid you can eliminate through your fecal sludge settling tank. You can use it to also, if you have an objective of elimination, to calculate the volume of the basin you have to implement and as a settling tank. In this slide, we have the example of the Camberen fecal treatment plant, which is the first fecal treatment plant implemented in Dakar. And we realize in this plant, as I explained, we have two settling thickening tanks that operate alternately. And after 1 week thickening and one week feeding and 1 week thickening, you realize that more than 90%, 97% of the liquid is as supernatant is sent into a wastewater treatment plant, an activated sledge close to this fecal treatment plant, and also we can send 60% of solid to the drying bed. Just you can realize how efficient is the solid liquid separation from this Camberen treatment plant. And as I explained, it is important before the treatment to implement a screening process in order to reduce the big quantity of solids, of garbage you have also in your fecal sludge. You need also an area where you can store the dry sludge coming from your drying bed. But a long storage period can improve the quality of this sludge and can allow all the kind of reuse of these dry solids.